Dear students, welcome to another day's lecture in elements of machine design of machine elements. Today we are going to start another unit. This unit is unit number 6. Totally in this subject there are 6 units. So out of 6 units we have finished 4 units. Now we are starting the 5th unit. Okay, so this unit's title is Design of Springs. Okay, all of you may have seen springs at some time. So first let us see the definition of spring. A spring is defined as an elastic body whose function is to distort when loaded and to recover its original shape when the load is removed. You see, mostly it is made of metal. You see, metals don't allow much flexibility. But when you make it in the form of a spring, then it distorts when it is loaded. And when that load is removed, it regains, it recovers its original shape. Okay. So this is the definition of spring. Now, what are the various applications of springs? Applications of springs. You see, that springs are used in cushions in your sofas, in cushions, in under your cycle seat, you can see, in motorcycles, for cushioning and for absorbing energy, for controlling energy uh, due to shock or vibration in car springs, railway buffers, in trains also. Oh, it will have big, huge springs. Otherwise, that jerks and all, if they are not isolated, then we will we will have very uncomfortable journey. Then aircraft landing gears, shock absorbers, vibration dampers. For all these purposes, it is used. You see, here is a picture showing different types of springs. Some of these springs, if you tear open your cushiony sofa, you may be able to see such kind of springs. Okay, various types of springs. So the first use is cushioning, absorbing the shocks and vibrations, or controlling the energy which is coming, used in car springs or railway buffers, uh, for vibration damping, shock damping, it is used. Okay, so the second thing is to apply forces, as in brakes. So when you are applying brakes, when you are going on a motorcycle or a car or in any automobile or even your cycle, you see, you apply brakes. So in that also springs are used. When you apply clutches, springs are inbuilt in the clutches. Okay, and spring loaded walls, in uh, we studied lever loaded safety valve, like that there are spring loaded safety valves also mounted on the boilers. So there these are used. These are all for as application for applying the forces. Okay, then we have to control motion by maintaining contact between two elements, as in cams and followers. You see, here you see, for maintaining contact between two elements, you see, you must have studied about cams and followers in the theory of machines. So these cams and followers cannot function without a spring there. numerous types of applications springs are used. They maintain contact between two elements, okay, and they control the motion, okay. And also in we have, as I told you just now, in brakes, in clutches also, for creation of necessary pressure in a friction device, they are used. Friction device, these two are friction devices, brakes and clutches, okay. Then restoration of a machine part to its normal position when applied force is withdrawn. A governor, a valve. See, if there is a speed governor in a turbine, then the governor uses a spring controlled valve to regulate flow of fluid through the turbine, thereby controlling the turbine speed. So for all these purposes, to control motion by maintaining contact between two elements in cams, as in cams and followers, they are used. Sometimes this question is asked for 3 or 4 marks. What are the applications of springs? So you should be able to list all these things. These are all very different applications. Another application is to measure forces. You must have seen spring balances. In spring balance, uh, even in villages, for weighing something, they'll be using. Did you see spring balance anytime? I will show you how it looks. Yeah, you see, these are the spring balances. This what is it doing here? It measures the loads. So for this purpose, it is used. Spring balances to measure forces, as in spring balances, and engine indicators also it is used. Engine indicator means, depending upon the force that is coming upon the spring, the needle will turn and it will show engine indicators. Then the another function, fifth function, is to store energy, as in watches, toys. You know, in the old nowadays everything is being operated by batteries. In the olden days, we used to get a spring watches. That means inside there will be springs, and we have to give key. You see, inside the watches, you will have springs like this. Even in some of the toys, you may have seen. And I can show you some more, things like this. Even things like this. You see, like this. You see, this is this thing that is wound here. These are all springs, and you see, if you open the watch and see, some tiny parts like this will be there. So you can see spring like this. Ah, this is called a spiral spring. The normal springs that we see, they are called helical springs, and these are spiral springs. Okay, now let us see about the different types of springs. First is the helical spring. Helical springs are like this, either like this or like this. The helical springs are made up of wire coiled in the form of an helix. So this shape now is called as helix shape, and it is primarily intended for compressive or tensile loads. You see, if it is spaced like this with gaps in the middle, then if load comes, it gets pressed and the length reduces. So that means it is taking compressive load. And if it is closely coiled like this, and like in some of the cycles for stand and other things, you may see such kind of springs. So you know here it won't take any compressive load, because it already coils are all touching each other. But if you pull it, no, that means tension this spring can be used. So this kind of helical springs, they take either compressive or tensile loads. And the cross section of the wire, the cross section of the wire from which the spring is made can be circular. You see, this is a circular. This is cut and shown. This wire can be circular. This is also circular, or it can be square also. Sometimes it can be rectangular also. Okay. So now here they have shown one compression helical spring, one tension helical springs. These helical springs have some advantages. These are the advantages. Easy to manufacture. Manufacture is easy. I can show you a small video, otherwise I'll see. These are available in wide ranges. You can see small wires, springs to big, very big springs, and different shapes, different lengths. So there are wide ranges available, and these are reliable. Reliable means, they are, we can trust them. Or in the middle, all of a sudden, without any reason, they won't fail. These have constant spring rate. We will see what is spring rate after some time when we see the terminology. Okay, different terms that are used regarding springs, and they have constant spring rate. Their performance can be predicted more accurately. Their characteristics can be varied by changing the dimensions. Here you can see uh, one spring. This is called a torsion spring. We'll see how torsion spring looks and what it can do. But to see how it is being manufactured. You see, this is a helical spring. One wire is being fed, and what you are getting is, you are getting a helical spring. And this helical spring is close coiled helical spring. It is used for tension. That's why a ring is also being formed. And you seeing different methods by which it can be made. So the ring is lifted now. See the top? Yeah, that is for holding. Okay, like that. These springs, these are all tension springs. They are made. You see, and this is a kind of, for uh, this is the compression spring. Are you seeing how fast, these things, different cams and so many automatic machines are used for these purposes. You see. Okay, you can explore some more in the YouTube. Second type of springs are conical or volute spring. Conical spring will be like a cone like this. Okay, volute spring will be, like a parabola shape, paraboloid. Okay, they are called. The conical and volute springs, as shown in the figure, are used for special applications where telescoping spring rate. You see here, initially where we saw, here we said these are having constant spring rate. Where did we say? Yeah, here in D. These have constant spring rate. Which ones? Helical. Because from the top to the bottom they're all of the same diameter. Okay. Whereas if you see here, you see, as in the top the diameter is less, bottom diameter is more. So therefore they have spring rate. You see, they are called scoping spring rate. Telescoping spring rate means what? The farther you go, the lesser, it will be. It's like you know if you are traveling by train, okay, see, the first 100 kilometers they may charge you some 50 rupees, and the next 100 kilometers they may charge you only 20 rupees, 70 rupees you may be able to go, like that. You see, that is called telescopic rate. Okay, that is not a uniform rate. Okay, and the conical spring as shown in figure is wound with a uniform pitch. The pitch is uniform. Pitch means what? The distance between from here to here, this to here to here, here to here. The pitch is uniform. Okay, the pitch is uniform. Whereas in volute springs are wound in the form of paraboloid with constant. Okay, see, both are constant pitch only, they said, but conical spring will have cone shape, and the volute spring will have parabola shape. Okay, and the next one is torsion springs. These springs, I showed you initially how that conical or the torsion spring was being made. Okay, these springs may be of helical or spiral shape. This kind of shape is called helical shape. This kind is called as spiral shape. Okay, the helical type may be used only in applications where the loads turn to wind up the spring and are used in various electrical mechanisms. You see, these springs are called torsional springs and torsional helical springs. These are, your exam writing pad, that has उसका चिमटा जो होता है उसमें springs होते हैं. So वो इस तरह के torsion springs होते हैं. Okay. And also your punching machine, पेपर को पंच करने वाला जो मशीन होता है उसमें टॉर्शन, इस तरह का टॉर्शन स्प्रिंग देख सकते हैं. The spiral type is also used where the load turns to increase the number of coils, and when made flat strip are used in watches and clocks. See, this can be made of a circular wire also, or if it is made of thin flat strips, okay, then it is used in watches and clocks. See some of the pictures I showed you initially. Then another type of spring is called as leaf spring. This is also called as laminated springs. You see, laminated springs, these are this is how in the pictures it looks. It will look. These are laminated spring. And where do you use it? This laminated means lamina means what? Like a thin sheet. Lamina means thin sheet. You can say like that. In hydraulics you study laminar flow, like that, layer upon layer. Okay, layer. So laminated sheet or laminated spring or leaf spring. So these are all like laminas. These are one lamina, two laminas, two, three, like that. Okay, these are leaf springs, also known as flat springs or carriage springs. Why carriage springs? Because for carriages you use. Carriage means horse carriage or car, bus, trucks. Okay, car they may not be using, but they may be using in buses, trucks, in the trains also. In trains you can see for heavy duty, that means more load where goods are being transmitted. माल गाड़ी में इस तरह के स्प्रिंग देखने को मिलते हैं. पैसेंजर गाड़ी में जो है ना हेलिकल स्प्रिंग देखने को मिलते हैं. आप देखो अगली बार जब ट्रेन में देखते हैं ना, ट्रेन के नीचे किस तरह के स्प्रिंग्स हैं. Okay, they consist of number of flat plates are known as leaves. Leaves ये पत्तों जैसे रहते हैं, एक के नीचे एक, of varying lengths. मतलब लेंथ अलग अलग है. पहले वाला बड़ा है, उसके बाद छोटा 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 होते गया. Okay, they are held by means of clamps and U-bolts. See, this is a bolt, U-bolt, in the shape of U-bolt, and also there are clamps also will be there. I will show you some other figure. These are mostly used in automobiles. The major stresses produced in leaf springs are tensile and compressive springs. You see, when we are designing, we need to know which types of stresses are coming. So here tensile and compressive stresses are coming. no need to the design of leaf springs, because in our syllabus we are going to design only the helical springs. But types of springs you should know. You see, I can show you some picture. You see, where in automobiles you see here, under the trucks, I know you will have springs like this. You see, these are all leaf springs. Okay, you see, like this, so many types of springs. Hmm. Okay, so see here, another picture is shown. This is a disc type spring. This is called Belleville spring. Okay. Now let us see about the materials for helical springs. See, the desirable properties of materials which are used for making springs are high fatigue strength, high ductility, high resilience, and also it should have creep resistance. These are the properties which a spring should have. Okay, mainly depends upon the service for which they are used. Service means what, in which place, for what purpose you are using. See, the severity of the service, the average service, or the lightness of the service. You see, it can be, you know, sometimes, very high loads and constantly, continuously it may be coming. That is a severe service. Average means intermittently maybe loads coming, or come less loads are coming. Light loads means sometimes it is used and the loads that are coming are less. So severe service means rapid continuous loading where the ratio of minimum to maximum load is one half or less, as in automobile wall springs. In automobiles you have walls, in IC engines. You see, sometimes, you know if some 200 2000 rpm is there, 3000 rpm is there. You see, that means per minute 3000 times it is being pressed. 3000 rpm means 3000 times pressed release. You see how severe uh, the application is. Wall springs. Okay, average service includes the same stress range as in severe service, but only intermittent operation. Only sometimes it is being used, as in engine governor speeds and automobile suspension speeds. Automobile suspension springs, no, you see, only when you come across a speed breaker, or when you fall into a ditch. These suspension springs will be working. Not like, automobile wall springs. Wall springs, per minute 1000 times, 3000 times opening closing means, see how severe that is. Here, no, the load is the same, but only that they are not operated continuously. Light service includes springs subjected to loads that are static, that means they are not changing, and are and vary. It is not vary in very frequent. What is this written? Or sorry, then it is very infrequently used. This is one word. Okay, infrequently varied, as in safety valve springs. In safety valve, no. Oh, in safety valve only when the boiler pressure is completely, is more than this for some time, 1 minute or something, it may be operating. Otherwise, this spring has no work. Okay, maybe, once in an hour, or 2 3 times in a day, this spring may be loaded. Otherwise it is not loaded. You see how much, how for varying applications things are being used. In wall springs, per minute 1000 3000 times opening closing. Automobile suspension springs, only when you are coming across some ditches or potholes, or speed breakers, then this will be applicable. Or in case, and this one in safety walls only once in an hour, or once in 2 hours, like that this will be operating. Okay, these are the different conditions. Okay, that is severe service, average service, and light service. The springs are mostly made up of oil tempered carbon steel wires. These are the materials. We are talking about materials. Oil tempered carbon steel wires having 0.6 to 0.7 carbon percent and 0.6 to 1% manganese. Music wire is another material. See, the tempered carbon steel is one material. Music wire is used for small springs. Then non-ferrous materials like phosphor bronze, beryllium copper, monel metal, brass, etc. may be used in special cases to increase fatigue resistance, temperature resistance, and corrosion resistance. So these are, you know, these steel springs are used. Then music wire, you see, if you find, you can find out the chemical composition of music wire also. And then non-ferrous materials like phosphor bronze, beryllium copper, monel metal, etc., for these things. Okay, it can be used. Okay, then helical springs are either cold formed. Now what we have, I have showed you some of the springs being made. They are not heated, so that means they are cold formed. Hot formed, hot formed means when it is red hot, you are winding it, you are making the spring. Okay, depending upon the size of the wire. Small wires, less than 10 mm diameter, are usually usually wound cold, whereas large sizes are wound hot. The strength of wires varies with size. Smaller size wires have greater strength and less ductility due to the greater degree of cold working. You see, the smaller wires have greater strength and less ductility because there is cold working involved. Now let us see the terms used in the helical compression spring. Okay, one is called solid length. Solid length means what? When see, if you take a spring and you completely press it in such a way that one coil is touching the other coil. You see, there are, see, I will show you. You see, if you talk about helical spring, you see, this is called wire diameter, this one. And from here to here is called the coil diameter. The big one is coil and the small one is the wire. Okay, coil diameter, wire diameter. Okay, so see, when the compression spring is compressed until the coils come in contact with each other, then the spring is said to be solid. Okay, that means it is no more spring. It has become like a solid, like a stiff thing. The solid length of the spring is the product of total number of coils and the diameter of the wire. You see, the solid length is simply n dash into d. This n dash is what? This is the total number of coils. Total number of coils means how many circles you made. One circle is one coil, two circles another coil, like that. How many coils are there? N dash coils are there. Why we are using n dash? Why not n? Because n is used reserved for some other thing. So n dash or n prime, you can say, that is being used for total number of coils. And d is the diameter of the wire. Diameter of the wire diameter. This is not coil diameter. Diameter of the wire, here I showed you. See, this is the diameter of the wire, this one. It's a small circle. From here to here will be the coil diameter. Okay, so for wire diameter we are using small d. Okay, now free length. Free length means what? In a compression spring, the free length means unloaded condition. There, when there is no load, how big it appears, that is the free length. But mathematically, if you have to write, you see, free length LF, or F, what is this? L, this F should be suffix. So LF, that means free length, is solid length plus maximum compression. You see, normally, no, it is the compression spring will not be compressed to such an extent that one coil will be touching another coil. Always there will be a clearance. Okay, so solid length plus maximum compression plus clearance between adjacent coil, which is final clearance. After pressing all without the full load, what is remaining is the called the clearance between the adjacent coil. So this um, free length formula can be the solid length is n dash d, this from here, and maximum clearance is delta maximum, and this clearance between the adjacent cell, maximum compression is delta maximum, clearance between the adjacent cell is 0.15 times of delta maximum. Okay, delta maximum means what? The maximum that the compression does, that spring can be compressed, that is delta maximum, and this clearance is normally taken as 15% of that, or 0.15 times. Okay, that is the free length, and free length can also be given by another equation, that is free length is n dash d plus delta maximum and n dash minus 1. You see, n dash is the total number of coils, and how many, if 10 coils are there, gaps will be how many? One less. Okay, when five fingers are there, how many gaps are there between the fingers? Only four gaps are there, no, like that. Okay, so n dash minus 1 into 1 mm. 1 mm is kept taken as the final clearance between the coils in the compressed condition. Then there is something called a spring index. Spring index is defined as the ratio of mean diameter of the coil to the diameter of the wire. Mean diameter of the coil is capital D and wire diameter is small d, and the spring index is given by capital letter C. So capital letter C is capital D by small d. So this is this also millimeters, this also millimeters. So spring index will not have any unit. It is a unitless index. Okay, and then spring rate. Spring rate, no, the spring rate is defined as the load required per unit deflection of the spring. That means what? अगर 1 mm दबाना है तो कितना लोड लगता है? 1 mm दबाने के लिए कितना लोड, कितना न्यूटन्स लगता है? ये जो है ना, इसको स्प्रिंग रेट बोलते हैं। अब स्प्रिंग इंडेक्स क्या होता है? स्प्रिंग इंडेक्स बोले तो कॉइल का डायमीटर ये कौन सा डायमीटर? मीन डायमीटर की बात कर रहे हैं, क्योंकि उसमें भी बाहर से मेजर कर सकते हैं डायमीटर का, अंदर से भी मेजर कर सकते हैं, नहीं तो वायर के बीचों बीच, मतलब वायर के जो सेंटर पॉइंट रहता है वहां से इधर का वायर के सेंटर पॉइंट तक, वो जो उसको जिसको मीन डायमीटर बोलते हैं। तो मीन डायमीटर डिवाइडेड बाय द डायमीटर ऑफ द वायर, इसको जो है ना स्प्रिंग इंडेक्स। तो स्प्रिंग रेट जो है ना, स्प्रिंग रेट को स्मॉल के से रिप्रेजेंट करते हैं, और ये W जो है ये लोड है, और डेल्टा जो है उसका डिफ्लेक्शन है। सो W का यूनिट न्यूटन होता है, डेल्टा का यूनिट मिलीमीटर होता है। सो स्प्रिंग रेट का यूनिट क्या रहेगा? न्यूटन अपॉन मिलीमीटर रहेगा। ओके, दिस इज स्प्रिंग रेट। ओके, स्प्रिंग रेट बोले तो अभी देखो, स्प्रिंग्स को कंपेयर करने के लिए स्प्रिंग रेट यूज कर सकते हैं। अभी देखो, कोई कम लोड से ज़्यादा दब जाता है, कोई उतना ही लोड से कम दबता है। तो कम दबता है मतलब क्या है उसका कम दबता है मतलब क्या है? 1 mm दबाने के लिए उसको ज़्यादा लोड लगता है, मतलब स्प्रिंग रेट ज़्यादा, मतलब क्या है? वो ज़्यादा जल्दी दबता नहीं है, ऐसा मतलब हो रहा ना। ओके, नेक्स्ट पिच। पिच, like in threads we have pitch. This pitch of the coil is defined as the actual distance between adjacent coils in uncompressed state. ये uncompressed state में pitch लेते हैं, compressed state में या semi compressed state में नहीं। लोड बिल्कुल जब नहीं है तब अपन pitch लेते हैं, ये याद रखने का। हाँ, अगर ऑलरेडी कुछ लोड उसके ऊपर है तो थोड़ा दब गया, तब पिच नहीं गिनते हैं। तो पिच क्या फॉर्मूला क्या होता है? तो फ्री लेंथ अपॉन द गैप्स। कितने गैप्स हैं? जैसा मैं बोला 5 उंगलियों में 4 ही गैप्स होते हैं, उसी तरह अगर एन डैश कॉइल्स होते हैं तो एन डैश माइनस 1 ही गैप्स होते हैं। ओके, दिस इज द पिच। Okay, the pitch of the coil may also be obtained by using the following relation, that is the pitch of the coil P is, अब देखो ऐसा भी बता सकते हैं, कैसे? The free length LF minus solid length LS upon N dash, प्लस डी, ये ऐसा भी बता सकते हैं. ओके. नाउ नेक्स्ट इज एंड कनेक्शंस फॉर कंप्रेशन स्प्रिंग्स. सी, अभी अभी जब स्प्रिंग रखते हैं, बनाते हैं, तो लास्ट में वो स्प्रिंग कैसे खत्म होता है. सी, ऐसा जो कंडीशन है, यहाँ पर ये दिया नहीं क्या. ओके. एंड कनेक्शंस. 1 minute, I will tell you. The, the springs, some springs are grounded like that. Some springs are, see the first one, this one is called as plain ends. यहाँ पर कुछ नहीं किया गया, ये plain ends है. और दूसरा जो है, इसको बोलते हैं प्लेन एंड ग्राउंड. ये ऊपर का थोड़ा सा ग्राउंड किया गया है. ओके. और ये ऐसा फ्लैट हो गया है, देख रहे हैं, यहाँ पर फ्लैट नहीं था. तो पहले वाला प्लेन एंड है, ये यहाँ लिखा नहीं है, मैं बता रहा हूँ, लिख लीजिए आप. और ये प्लेन एंड ग्राउंड एंड है. और ये तीसरा जो है, ये स्क्वेयर्ड एंड है. मतलब ये जो ना ऐसा तिरपा जा रहा है, मगर इसको ऐसा फ्लैट लाया गया है, तो ये स्क्वेयर हो गया. अभी सिर्फ आखिरी कॉइल को इस तरह बनाया जाता है. और ये जो है, ये स्क्वायर भी हो गया और ग्राउंड भी हो गया है. So this one is called plain end, this is called plain and ground end, this is square end, and this is squared and ground end. इस तरह का जो एंड कंडीशंस होते हैं. तो एंड कंडीशन, ये कौन से, किसके एंड कंडीशंस है? कंप्रेशन हेलिकल स्प्रिंग्स के एंड कंडीशंस है. ओके. नाउ एंड कंडीशंस फॉर टेंशन हेलिकल स्प्रिंग्स. टेंशन हेलिकल स्प्रिंग्स के लिए भी अलग अलग प्रकार के ये हो सकते हैं. ओके, like this, half hook, raised hook, and full twisted hook, like that. So don't worry about the tension helical springs. Normally the compression helical springs only will be designing. Here are some other materials, spring materials: hard drawn wire, oil tempered wire, chrome vanadium wire, chrome silicon wire, music wire, stainless steel wire, phosphor bronze, spring brass. These are the materials which can be used. Even stainless steels and other things also can be used. Okay, so I think today we will stop here and we will continue tomorrow. Thank you very much.